Everyone. In this demo, we are going to be looking at transactions. So we're going to look at a unsigned transaction, a signed transaction, and we're going to see just a very, very high level version of the transaction. There will be a deeper taking a look at in the transactions later on in the proof of work. But that's something when we go into the proof of work, we'll go into them. So we're going to take a look at the source code as usual, or our main Python code, because we're using one application to run all this, and we're editing code as we go along. So as we come back up here, everything's the same. So we just uncommented, or we commented out part 1. Now we uncommented part 2. So if we come down to part 2, we're going to print out the user's nonce, and this is to keep track of the transactions. So when the nonce is the same as before, that means the transaction is now queued instead of pending. In some environments, if you don't have the, depending on how you set it up, the nonce sometimes does not increase, and this depends on which parameters you're running with your Genesis, and that goes into Byzantium and Paris and Constantinople, all those types of EIPs that very, very, very in the detail stuff, but don't worry about that right now. So we're just going to take a very high level approach. So we have our nonce. This will always increase in our situation, so all of our transactions will always be pending. So we create the nonce, we get the VM state, we get the nonce for the sender. Since no transactions, it will be 0, or it should be 0. Then we come down here, we create a transaction, we have the nonce of the sender, we have the gas price is 0. We can increase this to make computation harder. We're going to send let's see, 100,000 with the value of this. So when the gas gets there, it will get returned to the sender. It'll get be received by the receiver. This is a weird way to do it, but this is the way that it was simple to do. Don't worry about it that much. So we're going to print out the unsigned transaction, then we're going to apply the private key, which we created above, to the transaction. And we're going to see the values that have been populated from that. And we're going to see that this is the signed transaction, and we're going to print out that transaction. So we're going to go back up here, and as always, we're going to run the file. We're going to see that, welcome to the EVM logger, and it went off screen. So let's get this in here so we can see everything. Resize it. Okay, cool. So we have our always the logger, we have our part 2, nonce is 0 because no transactions. So with ours, we're using Byzantium transactions, and this all depends on your setup with EIPs and everything like that. So that's just something to look into. For this demo purposes, we're just using Byzantium because it works. We have the nonce, the sender right here with the gas price, and this was into the that was put into the unsigned transaction. But we have 0 value and 0 data right here. So we end at data equals 0, or for the hex encoding right there. But then when we sign it, we have the signed transaction Byzantium. We still have the nonce all the way to the data B right here. But it gets added, what essentially gets validated is the sender sending the amount that it's sending. The V is the last 12 bytes, I believe, of the result, the remainder of R and S. R and S the first 14, the S I believe is the next 14, and this is just the leftover bit. All 3 of these get validated in proof of work, but we're going to take a look at those in the proof of work algorithm. That's just how the system works. But we see that when we do sign the transaction, we get these signatures, or the output of the signature that gets run through the validation of the proof of work for the transaction itself. So that's just something really cool about the Python EVM, where we can print out the unsigned transaction and the signed transaction right next to each other, right in, like within 3 lines of code, and it'll be repeatable. We can run this again, and since it's running the same exact values over and over again, we'll get the same exact thing over and over again. So this is fantastic for testing purposes, and we're going to take full advantage of this later on in the future demos. Thank you very much for watching, and I hope you consider watching the other videos in this demo.